My dear students, in this particular video, I'll be discussing the 20 most repeated topics when it comes to the NEET examination. So those topics which are almost asked every year in the NEET examination, and I'll be discussing these 20 concepts in just 15 to 20 minutes. So be with me till the end. I'll be, without wasting a lot of the time, I'll be directly starting with the concept number 1. My dear students, this is the first question which is asked in your NEET examination almost every year. What is the question? The question is about the spontaneity. One thing which you need to remember, what is that? For any process to be spontaneous, delta G for the system at constant pressure temperature, it should be negative. This is the condition for the process for the reaction to be spontaneous. For example, this is the type of the question which is asked. You are given with the reaction, its delta H value is given, its delta S is given. Now we are supposed to check at what temperature this reaction will be spontaneous. As I told you, for any reaction to be spontaneous, delta G should be negative. It should be less than 0. You must be knowing delta G is nothing but delta H minus T delta S. So this value is supposed to be negative. Delta H value is given to me as 80 kilojoules, which means 80,000 joules, minus delta S is given to me as 2 times T. 2 times T into T becomes 2T square. It should be negative. Or I can say 80,000 should be less than 2T square. Or I can say 2T square should be greater than 80,000. Or I can say T square should be greater than 40,000, which tells us that temperature has to be greater than 200 Kelvin. Basically, if you take a root on both the sides, you'll get here 200 Kelvin. So my dear students, I can directly say this particular reaction whose delta H was given, delta S was given, this particular reaction will be spontaneous only when temperature of the reaction is kept greater than 200 Kelvin. This is the first type of the question which is asked in your NEET examination almost every year. Okay. Moving on to the second concept, second question which is asked. What is that? Questions based on dipole moment. My dear students, whenever you are given with molecules like this, and you are supposed to check which molecules have more dipole moment, which molecule has lesser dipole moment. The first thing which you'll be always checking, that is electronegativity difference. Electronegativity difference between the atoms. Remember, more the electronegativity difference between the atoms, more is going to be the dipole moment. More the electronegativity difference between the atoms, more is going to be the dipole moment. This is the first condition which you are supposed to remember. For example, look at the first question. Here the bond is between O and H. Here the bond is between S and H. I would say electronegativity difference between O and H is more than that of S and H. So more the electronegativity difference, more is going to be the dipole moment. Again, bond is between N and H. Here the bond is between P and H. Electronegativity difference here is more, right? So more electronegativity difference means more is the dipole moment. Similarly, OH and NH. In case of OH, I would say electronegativity difference is more, so dipole moment is more, right? Similarly, in the last case, here the electronegativity difference is more, dipole moment is more. Perfect. Now, this is the case which I have to remember. Perfect. In this particular case, remember CH3Cl has got more dipole moment than that of CH3F. Perfect. And here, it is not because of the electronegativity difference, it is because of the distance factor. So you can remember it directly. Perfect. So this was our concept number 2. Concept number 3. Calculate the total number of spectral lines. The total number of spectral lines are calculated by the result N2 minus N1 into N2 minus N1 plus 1 divided by 2. Now you must be thinking, what is N2, what is N1? My dear students, N1 is basically your lower energy state, N2 is your higher energy state. For example, the electron is jumping from 6 to 1, right? How many total spectral lines are obtained? I would say total spectral lines would be equal to N2 minus N1, N2 minus N1 plus 1 divided by 2. So this is going to be 6 minus 1 is 5, right? And this is going to be 6 divided by 2. So 6 5s are 30, 30 divided by 2 is 15. So in total, I must say 15 spectral lines are obtained in this particular case. Just formula-based question, that's all, right? Similarly, my dear students, moving on to the fourth concept, that is calculation of nodes. There is a specific question which is asked about the nodes calculation. You need to remember just one thing. Total number of node is given by the formula n minus 1. Okay. Similarly, angular nodes are given by the formula L. Perfect. I think there is some electricity cut. I need to turn the lights off. Let them turn on the generator. Okay. Similarly, total number of nodes is n minus 1. Angular node is given by the value of L, and spherical node or radial node is given by the formula n minus L minus 1. Now you must be thinking, what is n and what is L? Let me tell you, n is basically your principal quantum number, and you know L is your azimuthal quantum number. L is your azimuthal quantum number. Now, my dear students, these are some questions by means of which you'll understand what do we have to do. For example, we have got 3s. In case of 3s, I must say n is equal to 3. And in case of s sub shell, L value is 0. So how many total number of nodes? Total number of nodes would be n minus 1. So 3 minus 1 is 2. Now, angular nodes. Angular node is given by the value of L. That will be 0. Right? So what about spherical nodes? So total nodes are 2. And there are 0 angular nodes. That means both the nodes are going to be spherical. Simple. Now 3p, for example. 3p. N value is 3. What is the value of L for p? For p, the value of L is 1. Now, total number of nodes. Total number of nodes, if you ask me, that's going to be n minus 1. So 3 minus 1 is 2. Angular nodes is given by the value of L. So L value is 1. Now, if you ask me about the spherical nodes, total nodes are 2, out of which angular is 1. That means 1 will be spherical node. Right? For example, 4D. N value is equal to 4. L value for D subshell. SPD. L value is 2. So total number of nodes will be n minus 1. So 4 minus 1 is 3. Now, angular nodes is equal to the value of L, right? Spherical nodes. Total, there are 3 nodes, out of which 2 are angular. That means 1 will be spherical. Perfect. I believe this is clear to everyone. Moving on to the next concept, my dear students, which is frequently asked, which is the concept number 5. You'll be asked about 1s and 2s. They will ask you, what is the psi versus r graph for 1s? Or what is the psi square versus r graph for 1s? So these are the graphs which you'll be remembering. For 2s, this is the psi versus r graph. This is psi square versus r graph. Remember it, they can be directly asked. These two can be directly asked, right? For 1s and 2s only, because in your syllabus, there is only 1s and 2s. Okay. Moving on to the sixth concept. That is exceptional configuration of chromium and copper, right? You know, this is the expected configuration. This is the expected configuration of your copper, chromium. And this is the expected configuration of your copper. Now, what is the actual configuration? Actual configuration of chromium is 3d5 4s1. This is the actual configuration. And actual configuration of copper is nothing but it is 3d10 4s1. And why this happens? The reason is mainly because of the exchange energy. So remember this as well. The reason is exchange energy. Perfect. So my dear students, these are the actual configurations of your chromium and copper. These are the expected configurations of your chromium and copper. Now, my dear students, concept number 6. Concept number 6 is related to bond order. They'll directly give you a species and they'll tell you what is the bond order of this particular species. Now, you have to remember a few things. All the 14 electron species will have bond order 3. 15 electron species, 2.5. 16 electron species, reduced by 0.5. 17 electron species, reduced by 0.5. 18 electron species, reduced by 0.5. Similarly, 13 electron species, again reduced by 0.5. 12 electron species, reduced by 0.5. 11 electron species, reduced by 0.5. 10 electron species, reduced by 0.5. Perfect. For example, let's say they are asking me what is the bond order of N2 molecule. Now, in case of N2, how many electrons will be there in total? One nitrogen atom has got 7 electrons, so in total 14 electrons. If it is a 14 electron species, its bond order will be 3. For example, they are asking me about O2 dinegative. O2 dinegative. In one oxygen atom, there are 8 electrons. So 8 2s are 16, right? And there is 2 negative as well. So 16 plus 2 makes it 18. So it's an 18 electron species. 18 electron species are bond order of 1. Right? And remember, bond order is directly proportional to bond dissociation energy, which is inversely proportional to bond length. And remember, all the isoelectronic species, those species which have same number of electrons, they'll be having same bond order always. Remember this particular point as well. For example, you have got Cn negative, you have got CO. This is a 14 electron species. Even this is a 14 electron species when you check. So these are isoelectronic. That means their bond order will be same. And all the 14 electron species, their bond order is always 3. There is a short question asked on this as well. Moving on to one more. Remember, oxidizing power is directly proportional to SRP, standard reduction potential. Reducing power is directly proportional to SOP. Okay, from this again a question can be asked. For example, these are few reactions. In all these reactions, gain of electrons is happening. Gain of electron means reduction. So these values are basically your SRP values. These are your SRP values. Now tell me, which one is more SRP? This has got maximum SRP. More the SRP, more the oxidizing power. So I would say this C tri-positive has got maximum oxidizing power, followed by your A positive and followed by B di-positive. This is the order of your oxidizing power. Now, this is one more question where you have to give the order of reducing power. My dear students, first of all, in every reaction, loss of electrons is happening. Loss of electrons is called as oxidation. So I would say these are your SOP values. SOP values, right? Now, which one has got more SOP? I would say this value is maximum, right? More the SOP, more the reducing power. So I would say C will be having maximum reducing power, right? Followed by what? Followed by this one, B, followed by what? Followed by the last one, that is A. This is the order of the reducing power. They can ask you a question on this as well. Okay. Moving on to ninth concept, E0 cell calculation. My dear students, whenever they ask you to calculate E0 cell is always equal to E0 cathode minus E0 anode. E0 cathode means SRP of cathode. E0 anode means SRP of anode. For example, understand how do we do it. Let's say these are the two electrodes. Now I'm connecting these electrodes externally and internally. I'll be getting a one complete cell. I'll be getting a complete cell. And I have to calculate its E0 cell value. E0 cell is nothing but E0 cathode minus E0 anode. Now, my dear students, check first. Is this SOP or SRP? If you look carefully, plus 2 to 0. Plus 2 to 0. Decrease in oxidation state means reduction. So this SRP. Similarly, 0 to minus 1. Decrease in oxidation state. Again SRP. So which one has got more SRP? This is more. More the SRP, more the tendency to undergo reduction. Right? And reduction takes place at cathode. So this is going to behave like your cathode. This is going to behave like your anode. Now, E0 cathode, SRP of cathode, that's 3 volt, minus SRP of anode, that's minus 2 volt. The value comes out to be 5 volt, right? So this is going to be your E0 cell for this particular cell, which was given to us. Again, a question can be asked from this, and these are the easy questions which I'm showing you right now. Concept number 10, what is that? Delta G versus E cell. Sometimes they'll ask you whether the cell will be working or not. Whether the cell will be working or not. You have to remember a few conditions. What is that? Any cell, my dear students, whose delta G will be negative or E cell will be positive. Delta G negative or E cell positive. Remember that cell works like a normal galvanic cell in which cell reactions will be spontaneous. Any cell for which delta G is positive or E cell is negative, that cell does not work. It does not produce any current. And any cell whose delta G is 0 or E cell is 0, we say this cell has attained the equilibrium condition. Remember this, it can be asked, a theoretical question to you in the examination hall. Moving on to one more concept, that is sign of W. Sign of W. Remember, whenever there is expansion, W value is taken as negative. And whenever there is compression, W value is taken as positive when it comes to chemistry. Perfect. Now, my dear students, if you look carefully, this is gas, this is gas. So on reactant side, we have got gases. On product side, we have got solid. So gases are getting converted into what? Gases are getting converted into solid. If gases are getting converted into solid, that means molecules are coming close. Close means compression. Compression means W positive. So the sign of W here is positive. Solid getting converted into gas. Solid into gas. Solid into gas. That means expansion. W negative. Right? Similarly, if you look carefully, in this particular case, this is in gaseous phase, this is in gaseous phase, even this is in gaseous phase. So you cannot decide on the basis of state. What do? Count the gaseous moles on left side. It is 1 plus 1 by 2. That is 3 by 2. 3 by 2 means 1.5. On this side, 1. So what is happening to gaseous moles? Gaseous moles are decreasing. Remember, if gaseous moles are decreasing, that means volume will be also decreasing. Volume decreasing means compression. Whenever there is compression, work is done on the system. W value is taken as positive. So W is positive here, right? There is one exception here, my dear students. H2O solid, when it gets converted into H2O liquid, normally what should happen? Normally it should be the case of expansion. So W value should be negative. But remember, in this particular case, W value is positive. It's a case of compression, basically. Okay, remember this as an exception. Now, moving on to the 12th concept, that is pH calculation. How do you calculate the pH? My dear students, pretty much simple. You have to calculate pH for 10 raised power minus 3 molar HCl. So first of all, HCl, how it undergoes dissociation, H positive plus Cl negative. The initial concentration of HCl was 10 raised power minus 3. This was 0, this is 0. Now HCl is a strong acid. It will undergo dissociation completely. So I'll be left with nothing. 1 gives 1, 10 power minus 3 gives 10 power minus 3. 1 gives 1, 10 power minus 3 gives 10 power minus 3. So if I ask you, what is the H positive concentration in the container? I'll say 10 raised power minus 3 molar. How do we calculate pH? pH is nothing but minus log of H positive ion concentration. So it is nothing but minus log of 10 raised power minus 3. So this value will come out to be 3 directly, right? Look at this one, 10 raised power minus 3 molar NaOH. Now NaOH is a strong base. How will it undergo dissociation? Na positive aqueous plus OH negative aqueous. Its concentration I had kept as 10 raised power minus 3 molar. This was 0, this was 0. Now this is 0. This will be 10 power minus 3. This will be 10 power minus 3. So if I ask you, what is the OH negative ion concentration in the container? It will be 10 raised power minus 3, right? Now if I calculate POH, P stands for minus log of OH concentration. So this value comes out to be 3. If POH is 3, then remember pH is equal to 14 minus POH, right? So 14 minus 3 is nothing but that is 11. So pH of this particular solution is 11, right? Now, in this one, remember it? It is going to be what? Its pH will be equal to 6.7. Its pH will be equal to 6.7, right? How? We have discussed all this in detail. You have to take the concentration of H positive from water into consideration as well. Okay, remember it directly, 10 power minus 7 molar HCl, its pH will be 6.7. And one more, if you have got 10 raised power minus 8 molar HCl, remember directly its pH value, it will be 6.95. It will be 6.95. These two values I want you guys to remember directly. Okay. Moving on to next concept, that is calculation of KSP. How do we calculate the KSP? My dear students, you have got MgOH whole twice. Now, how MgOH whole twice undergoes dissociation? It undergoes dissociation as Mg dipositive aqueous plus 2 times OH negative aqueous. Now, remember, if the solubility of this is S, this will be also S, this will be 2 times S because the stoichiometric coefficient is 2. Now, how do we write the expression for KSP? KSP expression is nothing but it is concentration of Mg dipositive raised by stoichiometric coefficient, concentration of OH negative raised by stoichiometric coefficient. So I would say KSP is equal. What's the concentration of Mg dipositive? That's S. What's the concentration of OH negative? That is 2S raised by 2. So this value comes out to be 4S cube. So I got to know your KSP value is nothing but that is 4S cube. So I can say S is equal to KSP divided by 4 whole raised by 1 by 3. Now, my dear students, as per the question, KSP value is given 2.4 into 10 raised per minus 14 divided by 4 whole raised per 1 by 3. Just the matter of calculation. Get the solubility which you are supposed to calculate, right? These sort of basic easy questions are asked in your NEET examination as well, right? Now, moving on to one more. That is concept number 14. That is pH of buffer. How do we calculate pH of acidic buffer? This is the formula to calculate pH of acidic buffer. And this is the formula to calculate pOH of basic buffer, right? For example, you have taken a weak acid. This is the salt of same weak acid with strong base. So this mixture is your acidic buffer, right? pKa value, sorry, this is not pK, this is Ka. Ka value is given. Ka value is given. We have to calculate pH. Since it's an acidic buffer, in case of acidic buffer, pH is equal to P of Ka. P of Ka. P stands for minus log. P stands for minus log. So P of Ka. P stands for minus log. Remember from now onwards, minus log of this particular value is nothing but it's 4.74. This will be used many a time, so remember the value directly. So I would say it is 4.74 plus a log of concentration of salt is 0.01 and concentration of acid is your 0.02. Or you can just interchange the values, keep this 0.02, keep this 0.01, right? So the calculation will be a bit easy. So this will be log of concentration of salt, which is 0.02, divided by concentration of acid, that is 0.01. So this will be log 2. Log 2 is 0.3. The value comes out to be 5.04, right? So like this, you can directly solve the question based on pH of acidic buffer. If they give you the basic buffer, then use this formula and calculate pOH. And once you calculate pOH, you can calculate pH as well, which is 14 minus pOH, right? My dear students, the 15th concept. You'll be given the question in which they'll say an ideal gas undergoes a change in state. An ideal gas undergoes a change in state. This was the initial pressure of ideal gas, initial volume, initial temperature. Final pressure of ideal gas, final volume, final temperature. Delta U during the process will be given. Delta H you will be supposed to calculate. Now tell me one thing. The pressure is changing, the volume is also changing. When pressure and volume both change, remember at that point of time, delta H is equal to delta U plus, this will be P2 V2 minus P1 V1. So pretty much simple. Delta U is given to me as 30 atm liter. P2 into V2, P2 into V2, 4 into 8 minus P1 into V1, 5 into 2, 10, right? So this will be minus 2. So this will be 28 atm liter. This sort of a question is also asked, which is directly your formula-based question. Okay, this was the 15th concept from which questions are frequently asked. Now, my dear students, in case of first order reactions, these are some shortcuts. Time taken to complete 75% of the reaction is equal to 2 times half-life. Time taken to complete 87.5% of the reaction, 3 times half-life. 90%, 99.9%, similarly 99%. Now, what kind of question can be framed? Let's say this is the reaction, A gives B. It follows the first order kinetics. Its half-life is given. Now, they are asking us to calculate T75. I told you a few minutes back, T75 is 2 times the half-life. 2 times 50, that means this will be 100 minutes. Answer is 100 minutes. Time taken to complete 99.9% of the reaction. That's nothing but 10 times half-life. So 10 into 50, that comes out to be 500 minutes. So these sort of questions, anything can be asked out of these. So remember these values directly. Perfect. This will be very beneficial for you. Now, order from half-life. Order from half-life. This is the typical question, my dear students, which is asked in the NEET examination nowadays. Basically, these sort of questions are asked in JEE examination. But they can copy it as well in the NEET because it's a pretty simple question. See, how do we have to do this sort of a question? My dear students, the concentration of reactant is given. Half-life is also given. Let me call this as A1. Let me call this as A2. Let me call this as T half 1. Let me call this as T half 2. You just have to remember one direct result. What is that? T half 1 divided by T half 2 is equal to A1 by A2 whole raised power 1 minus n, where n is the order of reaction. Now T half 1 divided by T half 2. T half 1 divided by T half 2. 4 by 2 is 2, right? A1 by A2. A1 by A2. This 1 by 2. Whole raised power what? 1 by n. So I can write 2 is equal to 2 raised power n minus 1. So 2 raised 1 is equal to 2 raised power n minus 1. That means n minus 1 is equal to 1. So I can say n value is equal to 2. So what was n? N was the order of the reaction. Pretty much simple. Okay. Similarly, guys, concept number 18, which is asked. N factor of the species that undergoes disproportionation. N factor of species that undergoes disproportionation. It is equal to n1, n2 divided by n1 plus n2. Now understand. If I ask you what is the oxidation state of oxygen here, -1, oxygen -2, here 0. -1 to -2, decrease in the oxidation state. -1 to 0, increase in the oxidation state. Whenever you see oxidation state of same element increasing as well as decreasing simultaneously, remember that species undergoes disproportionation. And how do we calculate its n factor? Its n factor is calculated as n1, n2 divided by n1 plus n2. Now, how do we get n1? How do we get n2? See, -1 to -2. -1 to -2. What is the change? Change is final minus initial. The value is 1. 1 is the change for one oxygen. I have 2. So 1 into 2 is 2. So n1 value is equal to 2. Now similarly, -1 to 0. -1 to 0. Final minus initial. The value is 1. 1 is the change for one atom. I have 2. So n2 value is also 2. So this becomes 2 multiplied by 2 divided by 2 plus 2. The value comes out to be what? The value comes out to be 1. So if you got the n factor of H2O2, equivalent mass is nothing but molar mass divided by n factor. Molar mass of H2O2 is 34 grams. Its n factor is 1. So the answer will be 34 grams. Even this was the question which was asked in AIMS as well. This particular one. A simple basic one. Moving on to the next concept. That is concept number 19. Sometimes they'll ask you the question wherein they'll ask you to balance the reaction in acidic medium. I'll show you a simple shortcut by means of which you balance the reaction in acidic medium. My dear students, get the oxidation state of chromium. It is +6. Tin here is in +2 oxidation state. Here tin is in +4. Here carbon is in +4. Now understand. +6, just this not carbon dioxide, sorry. This is chromium tripositive, okay? This is chromium tripositive. So its oxidation state here is +3. Its oxidation state is +3. Now, +6 to +3, change. Final minus initial, the value is 3. 3 is the change for one atom, I have 2. So 3 2s are 6. That means its n factor is 6. +2 to +4, change. Final minus initial, the value is 2. Right? N factor is 2. Now crisscross these n factors. This 2 will go here, this 6 will go here. After crisscrossing the n factors, balance all the atoms except hydrogen oxygen. So we have got 4 chromium atoms here, 4 chromium atoms. 6 tin and 6 tin. Right? So I balanced all the atoms except hydrogen oxygen. Now balance oxygen with the help of water. How many oxygen on this side? 7 2s are 14. So 14 oxygen on left side. So add 14 water molecules on right side. Oxygen is balanced. Now balance hydrogen. 14 to 28 hydrogens on this side. This side is hydrogen deficient. So add 28 H positives on this side. The reaction is balanced. A simple shortcut by means of which you can balance the reaction in acidic medium. Okay. Similarly, guys, one more concept which is frequently asked, that is application of oxidizing and reducing agents. Sometimes they'll ask you a question about strength of oxidizing agent, strength of reducing agent, strength of acid, strength of base. Remember, strength of oxidizing agent is directly proportional to oxidation state of central atom. Inversely proportional, directly, inversely. For example, this is the question. In this question, you have to give the order of acidic strength, right? Get the oxidation state of the central atom. Here the central atom will be in +7, here it will be in +5, here it will be in +3, here it will be in +1. More the oxidation state of central atom, more is going to be the acidic strength. Here you have to give the order of oxidizing agent. Which one is strong oxidizing agent? Calculate the oxidation state of central atom. So this is +7, this is +6. More the oxidation state on the central atom, stronger is the oxidizing agent. Oxidation state of nitrogen, here is -3, here sulfur is -2, right? We have to give the order of reducing agent. So strength of reducing agent is inversely proportional to oxidation state of central atom. So lesser the oxidation state of the central atom, more is going to be its reducing nature, right? I mean, stronger is going to be the reducing agent. Pretty much simple. So 20 concepts till now. My dear students, one more concept which I'll be discussing here. What is that? That is orbital angular momentum. How do we calculate orbital angular momentum? That's under root of L into L plus 1 multiplied by h upon 2 pi. This is a direct formula by means of which you calculate orbital angular momentum. They can give you, for example, 2p. They can give you 3s. They can give you 4d. And they can ask you, calculate their orbital angular momentums. How do you calculate orbital angular momentums? Understand. For p subshell, the value of L is 1. For s subshell, the value of L is 0. For d, value of L is 2. Now, formula. orbital angular momentum is equal to under root of L into L plus 1. So 1 into 1 plus 1 multiplied by h upon 2 pi. 1 plus 1 is 2. So this will be root of 2 h upon 2 pi. This is the answer of this question. L is equal to 0. If L is 0, orbital angular momentum is 0. L is equal to 2. So this will be under root of L into L plus 1 h upon 2 pi. So this one more question which is frequently asked in your NEET examination. So you need to have an eye on this one as well. And my dear students, one last concept, that is the spin magnetic moment. How do we calculate the spin magnetic moment? Spin magnetic moment is given with the formula under root of n into n plus 2. Under root of n into n plus 2. Where n represents the number of unpaired electrons. For example, I've got Fe di positive. I have to calculate spin magnetic moment of Fe di positive. Iron has got the configuration of 3d6 4s2. Now this is basically Fe di positive. So take 2 electrons out. So the configuration is 3d6. In 3d6 configuration, there are 4 unpaired electrons. So put the value of n as 4 under root of 4 into 4 plus 2. 4 plus 2 is 6, 6, 4, 24. So root of 24 Bohr magnetrons is the final answer of the question. So these are some repeated concepts, my dear students, which are asked in the NEET examination. Please have a proper eye on these questions. And I'm pretty much sure from these concepts, lot of concepts will get repeated in your upcoming NEET 2026 examination.